The lesson that you are watching right now is about basically SOHCAHTOA, what you had done in geometry, angle of elevation, angle of depression. So let's get some words down. So if you go over example 5, and you can work along with this, a surveyor can measure the width of a river by setting up a transit at point C. So he or she puts a little something over here called a transit, and knows that he or she needs to focus on this point, taking a sighting of point A on the other side. So after turning through an angle of 90 degrees, so this person knows that he or she is going to make a 90-degree angle there and walk over 300 meters to point B. So we know that this leg of the triangle is 300 meters. I know that's kind of hard to see. We also know that using the transit at B, the angle theta is measured and found to be 25 degrees. So the acute angle at point B is 25 degrees. We're looking for the width of the river, so we're looking at this. And what you remember from geometry is that we have the opposite leg that we're looking for, we have the adjacent leg, and we have an acute angle. So opposite and adjacent is tangent, so I'm just going to write down the tangent of 25 degrees is opposite over adjacent, so B is equal to 300 times the tangent of 25 degrees, and I'm just going to plug that right in my calculator. I'm going to make sure that I am in degree mode, and I am, and I'm just going to type in 300 times the tangent of 25, and I'm going to get B is 139 point, let's call it 0.89 meters. Okay, so easy, you're given the right triangle. Gets a little bit trickier when we're talking about angle of elevation, and you can see the diagram. An angle of elevation is the angle above the point of view. So we have somebody's looking for the height of a tree, and we have a surveyor who measures the distance from the base of the tree. So here's our tree. Okay, and the surveyor is measuring the distance from the base of the tree to some other location and measures the angle of elevation. So instead of looking straight ahead, the surveyor is going to look up at the top of the tree. This is the angle of elevation, an angle above the horizontal. So for part A, we are given that the horizontal distance from the tree is 48 feet, and the angle of elevation is 65 degrees, and we are looking for the height of the tree. So once again, we have an angle, we have the opposite, we have the adjacent, that's tangent, so I'm just going to write tangent of 65 is the opposite over 48. Multiply both sides by 48, so we get rid of the fractions, and then I know x is just going to be 48 times the tangent of 65, which is going to give me a height of 102.94 feet. For part B, they want us to make this a little more realistic, so we're going to say that the surveyor's instrument is 5 feet above the ground. So we really have something that looks like this. So when I look at my right triangle, I have to worry about a little piece that's also going to be 5 feet off the ground. So I can definitely use exactly what I had done before. So I still know that this side of the right triangle is 102.94, but then the tree also has another 5 feet of it. So my total tree height is going to be 107.94 feet. And for part C, suppose you also want to know that the distance from the survey point to the top of the tree. So we have the tree, we know this is 48, and I'm looking for this. Well, we have a number of ways we could look for this. Really, the best way is to use what you were given. So I have the adjacent leg. I'm looking for the hypotenuse. So that's definitely going to be cosine. I'm going to do this on another sheet of paper. And I would write the cosine of 65 degrees is equal to the adjacent over the hypotenuse. Personally, I would multiply both sides by x first to get rid of the fractions. And then I have x times the cosine of 65 degrees is 48, and I would just divide by cosine of 65. right? So I know that x is going to be, once again, 48 divided by the cosine of 45, I'm sorry, cosine of 65, which is going to give me 113. So the length of that hypotenuse is 113.58. I don't know why you would want to know that. Okay, our other option is to use a little Pythagorean theorem, that if this is 102.94 and this is 48, I can say 102.94, and in fact it would be better to take my unrounded version, so in fact I'm going to clear that out, and I'm going to go up to my unrounded version. I should have just grabbed this. Forget it, I'm going to use my rounded version. 102.94 squared plus 48 squared. I know that's my hypotenuse squared, so I'm going to take the square root of that, and I get 113.58, just as before.